Hi, lovely people. My name is TTJ Richie and welcome to my online tutorials. Our discussion on discrete mathematics and graphs today will be on a very important theory when it comes to graph, which is called the handshaking theorem. So before the video ends, I will tell you what the handshaking theorem means. Then we'll solve some sample questions using the handshaking theorem. This will be a very interesting engagement, so please be my guest. So before we can understand the handshaking theory very well, let's learn or let's revise our knowledge on how to find the degree of each of these vertices. Please do well to check out my videos on how to find the degree of a vertex on YouTube. It will help you understand this better. So now let's find the degree of the vertex A. Remember, we said the degree of a vertex is the number of edges that are incident on that vertex. So the degree of a vertex, let's count the number of edges that are incident on the vertex A. That's 1, 2, 3, 4. So we say the degree of the vertex A is 4. Now let's find the degree of the vertex B. So the degree of the vertex B, how many edges incident on the vertex B? That's 1, 2, 3. And this is the fourth one. So we say the degree of the vertex B is 4. Now let's find the degree of the vertex C. The degree of the vertex is how many edges incident on the vertex C? That's 2. So we can say that the total number of degree of all the vertices is equal to the degree of the vertex A plus the degree of the vertex B plus the degree of the vertex C. And that gives us 4 plus 4 plus 2. And that's what? That's 10. Now let's find the total number of edges of this graph. Total number of edges . The total number of, so let's count the number of edges. We have 1, 2, 3, 4, 5. So the total number of edges of this graph is 5. Look at it. The total number of degrees is 10. And the total number of edges is 5. Please, did you get some relationship between them? Now, so let's look at another graph. Let's look at this graph. Let's try to find the degree of all the vertices of this graph. So the degree of vertex A. So we have 1, 2, 3, 4. So we can say the degree of vertex A is 4. Now let's find the degree of the vertex B. The degree of the vertex B is, that's how many vertices, how many edges incident on the vertex B. So we count 1, 2, 3, and this is the fourth one. So we can say the degree of vertex B is 4. Now let's go to the degree of vertex C. Now where is the vertex C? This is having a self-loop. Remember we said self-loops add 2 to a degree. So let's count the number of edges here. 1, 2, 3. Then the self-loop will add 2 more to it. That becomes 5. So we say the degree of the vertex C is 5. Now let's find the degree of the vertex D. So this is the degree of the vertex D. The degree is 1, 2, 3, 4. So the degree of the vertex D is 4. Let's find the degree of the vertex E. So the vertex E, this is 1 edge. Then it's having a self-loop. Add 2 more to it. That becomes 3. Now let's find the total number of degree of all the vertices. So that's 4 plus 4 plus 5 plus 4 plus 3. Now 4 plus 4 is 9. 9 plus 5 is 4 plus 4 is 8. 8 plus 5, that becomes 13. 13 plus 4 is 17. And 17 plus 3, that will give us 20. Now let's find the total number of edges. Total number of edges. So the total number of edges of this graph. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So the total number of edges is 10. So you realize that the total number of degree is 20 and the total number of edges is 10. Can you see the relationship between them? The first graph we found, you see that the total number of degree of all the vertices is 10 and the number of edges is 5. Then the second one, the total number of degree of all the vertices is 20 and the number of edges is 10. So you can see that twice the number of edges is equal to the total number of degree of the vertices. I hope you get that. So when the edges are multiplied times 2, that becomes the total number of degree of all the vertices of the graph. I hope you get that. So that's all what the handshaking theory says. So the handshaking theory states that the sum of the degree of all the vertices of a graph is equal to twice the total number of edges. So we say that the sum of the degree of all all the vertices of the graph is equal to twice the number of edges. I hope you get that. So that's what the handshaking theory says. The handshaking theory just says that the sum of the degree of all the vertices of a graph is equal to twice the total number of edges. And we have looked at the proof of it in the two graphs that we talk about. Now, we'll learn how to use the handshaking theory, or we can apply the handshaking theory to solve some sample problems. So let's look at our first example. They say, how many edges are there in a graph with 10 vertices, each of degree 6? So how are we going to do that? So remember, we said that the handshaking theory says that the sum of degree of all the vertices is equal to twice the number of edges. I hope you get that. So they say, how many edges are there in a graph with 10 vertices, each of degree 6? So if the graph is having 10 vertices and each of the vertices is having degree 6, then the sum of all the vertices is the number of vertices times the sum of the degree of all the vertices is the number of vertices times the number of degree that each of them is having. Then we can say that the total number of degree of all the vertices is equal to the number of vertices, which is 10 times 6, and that will give us 60. Remember, the handshaking theory says that the sum of the degree of all the vertices is equal to twice the number of edges, and the sum of the degree is 20. So we say 20 is equal to 60 is equal to 2e. So we divide both sides by 2. Realize that our e is 30. Then we can say the graph has 30 edges. I hope you get that. This is very, very simple. Let's look at the second example. Please, you can pause the video and try solving the second example. After that, you compare answers with one. Now try and compare answers. They say a graph has 24 edges and the degree of each of the vertices of the graph is 4. Find the number of edges. Find the number of vertices. Find the number of vertices. So they say that the graph has 24 edges and the degree of each of the vertices of the graph is 4. We should find the number of vertices. Remember, the handshaking theory says that the sum of the degree of all the vertices is equal to twice the number of edges. Then if the vertices, each of them is having a degree of 4, then we can say that the sum of the degree of all the vertices is equal to v, which is the number of vertices, times the degree, which is 4. And this will give us 4v. I hope you get that. So, and the number of edges, remember, is 24. Then we can use the handshaking theory, which says that the sum of the degree of all the vertices is equal to twice the number of edges. Or the sum of the degree of all the vertices, that's 4v. 2 times the number of edges, which is 24. So now we can divide both sides by 4 to find the number of vertices. So v will be equal to 4 going to 24 6 times. You have 2 times 6, and that will give us 12. Then we can say that the graph has 12 vertices. 12 vertices. I hope you get that. This is pretty very simple, and I know you will get the same answers with one. We solve more examples on this so that you'll be abreast with the concept. So we look at our third example on the application of the handshaking theory. Is it a graph has 21 edges, 3 vertices has a degree of 4, and all other vertices has degree 2. We should find the total number of vertices of the graph. So in a graph, we know that the graph is having 21 edges, and we also know that 3 vertices of the graph has degree. Each of them has a degree of 4. and we notice that all other vertices has a degree of 2. Okay, our task is to find the total number of vertices of the graph. So we need to find the total number of the number of vertices that each of them is having a degree 2. Then we add it to the number of the 3 vertices that we already know, and that becomes the total number of vertices of the graph. So we say the total number of vertices of the total number of degree of a vertex is equal to twice the number of edges from the handshaking theorem. And the number of edges, remember, is 21. So what we need to find the total number of degree of all the vertices. So if 3 vertices have a degree of 4, their total degree will be 3 times 4. I hope you get that. Then we know that all other vertices have degree of 2. We don't know any all other vertices, so we represent it by a subscript a. So times the number of that vertices times 2, which is the number of degree of each of them, will give us the total number of degree. Then we can say that the total number of degree of all the vertices will be the ones, the 3 vertices having degree 4 plus the vertex plus twice the other vertices that we don't know. So this will give us 12 plus 2v subscript a. So from the handshaking theorem, we know that the degree of all the total number of degree of all the vertices is twice the number of edges. Then this is 12 plus 2v subscript a is equal to twice the number of edges, which is 21. So you can say 12 plus 2v subscript a will be equal to 42. So 2v subscript a will equal to 42 minus 12. Then 2v subscript a will equal to 20. So that 42 minus 12, that's 30. It will be 30. Then we divide both sides by 2. Then we can say v subscript a is equal to 15. So we know that 15 vertices has degree 2 and 3 vertices has a degree of 4. Then the total number of vertices, will be equal to the 3 vertices with degree of 4 plus the 15 other vertices with degree of 2. So the total number of vertices becomes 18. I hope you get that. So this is very simple. We'll solve one more example on this so that you understand better. So we'll look at our 4th example. Before we do that, please remember to subscribe to my YouTube channel if you are here to, or if you are new to this channel. Hit that like button and share my videos. Comment. Your comment keeps me going. So help comment my videos and I can record more mathematical content for you. So they say a simple graph has 35 edges. 4 vertices has degree 5. 5 vertices has degree 4. And 4 other vertices has degree 2. So all other vertices has degree 2. We should find the number of vertices with degree 2. Then the total number of vertices of the graph. A simple graph has 35 edges. 4 vertices has degree of 5. That means each of the 4 vertices has degree 5. 5 vertices has degree 4. 5 vertices is known to have a degree of 4. Each of them have a degree of 4. And 4 other vertices has a degree of 3. 4 vertices is known to have a degree of 3. And the remaining vertices has degree of 2. Then we are asked to find the total number of vertices with degree 2. We should find the number of vertices with degree 2, then the total number of vertices of the graph. So why do we do this? So remember, from the handshaking theory states that the sum of degree of all the vertices is equal to twice the number of edges. This is very, very important. And the number of edges of the graph is 35. Now we need to find the total number of degree of all the vertices. So the total number of degree of all the vertices will be equal to, if 4 vertices has degree of 5, Then their total degree there will be 4 times 5. Then plus, if 5 vertices has a degree of 4, then their total number of vertices will be, the total number of degree will be 5 times 4. Then plus, 5 vertices has a degree of 4, and 4 other vertices has a degree of 3. So their total number of degree will be 4 times 3. Then, all other vertices has the degree of 2. Then we can say that all other vertices times the number of the degree of each of them will give us their total. So when we polish this very well, 4 times 5 will give us 20, 5 times 4 will give us 20, 4 times 3 will give us 12, and this will give us 2v subscript, 2v naught. So 20 plus 20, that's 40. 40 plus 12, that becomes 52, then plus our 2 subscript v. Then this becomes the total number of degree of all the vertices. So we find the total number of degree of all the vertices to be 52 plus 2v, 2 subscript v, where v represent all other vertices that is remaining. So we can say from the handshaking theory that we said 2, the total number of degree of all the vertices is twice the number of edges. So we can say 52 plus 2 subscript v0 will be equal to 2 times the edges. And what's the edges? The edges is 35. So 2 times 35. So we can say 52 plus 2 v subscript o, that remain, where v subscript o is the all other vertices, will give us 70. 2 times 35 will give us 70. Then we can say 2 v naught is equal to 70 minus 52. 2 v naught will be equal to 18. We divide both sides by 2. So our v naught will be equal to 9. Then we can say that 9 vertices has a degree of 2. I hope you get that. And the second aspect, having found that 9 vertices have a degree of 2, we add it to all other vertices to get a total number of vertices. So we say total number of vertices will be equal to, so let's say 4 vertices has a degree of 5, so we know that we have 4 vertices there. Then 5 vertices has a degree of 4, we know that we have 5 vertices there. Then they say 4 other vertices has a degree of 3. That means we have 4 vertices there, so plus 3. Then all other vertices has a degree of 2. Then that all other vertices is 9, so we add 9 to it. So 4 vertices has a degree of 5. That means we have 4 vertices there. 5 vertices has a degree of 4. We have 5 vertices there. And 4 other vertices has a degree of 3. That means we have 4 vertices there. So this will be 4, not 3. I rather wrote the degree inside of the vertex. Then plus all other vertices that have a degree of 9. So we add everything. 4 plus 5, that's 9. 9 plus 4, that's 13. Then 13 plus 9 will give us 22. So we say the total number of vertices is 22. I hope you get that. Please play over the video, and I know you will get this concept. We have been talking about the handshaking theory and how to use the handshaking theory to solve some sample problems. Please remember to subscribe to my YouTube channel before we sign up. Until we meet again, my name is Kepsi.